Hey kids, categorical data. So this is a picture of the Titanic, and there's a copy of the notes that you can get from our Schoology page that follow along with this, so you don't have to copy everything off the PowerPoint. Otherwise, you're going to have to pause the video and copy things down as we go. But there is a handout that goes along with this. So we have some Titanic data launched in May of 1911 and quickly sank soon after. And when it did, we lost 818 passengers, 684 crew, and our total loss was 1,502, which ended up being 68% of the entire people on the ship. So we have a distribution, and we have actually two different distributions here. The first, we break it down by first class, second class, third class, and then the crew. So these people have the most money, these people have the least money. And this is the frequency or the counts that they appeared on the ship. We also can take the total that we have here and divide each of these by the total and get the proportions or the relative frequency, the percentages of first class, second class, third class, and crew. And if we add these together, we get 100% of the passengers and crew, I guess, on the ship. So frequency counts, relative frequency, percentages or proportions. Now with the next few slides, we have some errors in graphical displays, such as this one, where you can see, okay, first class had 325 people, so a little bit more than 300, we have that. The second class is 285, a little less than 300. But the problem with that is this is violating something called the area model. When we look at the ship, we see the area that it's taken up, not just the length. And so this violates the area principle. You can see that if we took 4 of these first class ships, we could probably fit them here inside the crew, but 4 times the first class number of passengers is not the crew. So it violates this principle. And instead, we want not to have different areas for each thing that we're just looking at one variable, just number of people. So we use a bar graph instead. A bar chart displays the distribution of the categorical variable, showing counts, but the width of each bar is the same so that we have all of these looked at proportionally. So we know, okay, first class comes up to here. Here's my 325, etc. So this stays true to the area principle. So we're comparing apples to apples. And now we also, when we have this categorical data, we leave spaces here. Another thing that I look at often to decide if it's categorical is if I switch third class and crew, would it really break the display? And with categorical data, no. We may want them to go in some ascending order for the sake of convenience or because it makes sense, but it wouldn't hurt the display if I switched second and third or crew and first. Relative frequency divides. So we have percentages, so I can see the crew made up 40% of the passengers. We also use relative frequency to determine how big of an area we're going to get in our pie chart or circle graph. We have to take each of those percentages, 40-something%, and multiply by 360 degrees, and that is problematic. So you often on the AP exam, we're not making circle graphs, but they are just fine for us to see, oh, look, this relatively to crew, how much more or what a bigger proportion of the crew there is. When we do that, though, if we lay it flat here like we do in Excel, if you ever tried to make a graph in an Excel document, you lose that from the perspective, and we can't quite see how much the first class relates to the crew when it's laid flat. So don't do that. We also can sometimes have problems in our graphical displays because, probably some of these categories overlap, or the people that responded would have, but if we keep each of their response separate, then we end up with things that add to be more than 100%. All right, back to the Titanic. So a two-way table is a two-way table because it has two variables that we're looking at. Here, survival is a variable, and class. This is bivariate categorical data here. So whether you made it out alive or you died at sea, and then what class you were when that happened, first class, second class, third class, and crew. We have marginal distributions or marginal totals. They're the values in the margins. And we use those marginal distributions to help us determine relative frequencies. So if we have our data here and we're asked something like what percent of the people on the Titanic died, when we look at this and we're saying, okay, this is really of the people is out of all of the people on the ship. That's out of 2201. So we're thinking about what are we dividing by here? What is this total sample space? And so what percent of the people on the Titanic died? Well, died is 1490 out of all the people, 2201, and we get 67.7%. What percent of the people, again, of the people out of 2201 were surviving crew, alive crews? So I have 212 out of the 2201 is 9.6%. Now here is a little asterisk to point out, oh, this is different. We get what percent of the survivors. Now, when we're talking about of the survivors, now it's out of only those that lived. So our denominator goes from of the people to of the survivors, and we have 203 out of 711. What percent of first class survived? So we have of first class, so out of the first class survived, alive out of first class 203 out of 325 is 62.5%. So really pay attention to what we're talking about. Of whatever is our sample space here. Now we also look at these as conditional distributions. If we separate them, all right, we had alive people, we had dead people by their class. So there's on the condition of survival. And if I want to know what proportion of the alive people were first class, I can say 203 out of 711, 118 out of 711, and so on to get these percentages. We could do the same thing for the deceased. Now you would go through and divide all of these to make sure. 528 divided by 1490 here. 178 divided by 711 here. Now we have all these proportions, and we may be asked to do something with it. Because this is bivariate, two variables, and categorical, one of the most common kinds of graphs we're going to make is something called I'll get to that in a second. We always want to compare proportions. We made that point a minute ago maybe, but compare proportions, not counts, because the sample sizes are much different. 711 is way different than 1490. So when we are comparing them within the proportions, we want to compare apples to apples. So a segmented bar graph is what I was getting to. We're going to make a segmented bar graph, which displays the same information as a pie chart, but in bars. Easier to make, especially on the AP exam, because we don't have to figure of 360 when we're trying to figure out what size to make things. So you might have something, we're going to make this segment bar graph, and we're going to take these two categories, alive and dead, and we're going to make a proportion. Now, this is going to be animated here in a minute, but I'm just going to show you how I would do this by hand first. I'm going to pick any distance, really, and say, okay, there's 100, and then I'm going to go halfway. Here's 50. Between those two, here's 25, 75 above, and then halfway here's 25, right? So I have a relative, and these are all percentages, relative frequency. Okay. Now, if I'm going to graph, I have a choice. I can start with first class down here, or I can start with the crew. And if we're building up, maybe the first class people would like to be on the top of this graph. So I'm going to start with the crew, and I'm going to go, all right, we got 29.8%, which is more than 25%. So if we're thinking about how this breaks down proportionally, right, we're going to have like 25, 30, 40, 50. So I'm going to just go slightly above, and I'm going to say these are my crew. And then I'm going to take that 29.8% and I'm going to add the third class. So I'm combining these and I get 54.8. So 54.8 north of 50. No one's going to get out a scale and make sure you get this exactly right, but we want to be close, right? Be on the right side of 50. So this, and you notice like these look fairly similar. Hopefully the crew looks a little bit bigger. Crew and third class are fairly close, so they should look kind of close. And this is third. And then we're going to go and add in 16.6, and I get 71.4, which is short of 75. So I'm going to go up to, but they're not too close. Maybe that's a little bit too tall, actually. Something in here. Okay. So here's second. And I don't have to even mess with adding 28.6, so I know it's going to add to 100. Ooh, my segmented bar graph is kind of leaning. We have the Tower of Pisa here. This is first. Okay, so there I've made this. Now I'm going to go back to the animation, but I wanted to at least show you kind of how I'm building it as I add together, because the animation doesn't go in steps. And so if we combine those and graph them out of proportions, here we are. Now I can look and I can see, compare apples to apples, crew to crew, alive and dead, third class to third class, second class to second class, first class to first class. Now we use that and we're going to write some sentences to describe the association. When you see that phrase, that's a really big one, describe the association between these two categorical variables. And the first thing that jumps out, if we're going, is, oh man, look at this. The first class, way higher proportion of first class survived than died. So the first class passengers make up a much larger proportion of the alive group than the dead group. We're almost like 3-to-1 here. I mean, this is more than that, right? So much higher proportion of it in the alive group than the dead group. Second class is slightly greater in the alive group, 17% to 11%, like 1.5 times as big. But then it flips. We have a higher proportion of third class that are deceased and a higher proportion of crew that is deceased. So it turns out there looks to be an association between your status in life, or how much you can afford on a ticket for the Titanic at least, and whether or not you were going to be part of the alive group or the dead group. There is an association between those. People with higher status tended to stay alive, and people with lower status tended to be a higher proportion of those that died. When describing association between categorical variables, we must compare proportions, not counts. Now, we could have flipped that, and instead of breaking it down by alive and dead, we can have first class. You can still see a much higher proportion of alive. Second class, third class, and crew. Well, this animation is not going to go so well. All right, so we could have done it either way. Still see the same association. We could also have done comparative bar graphs where we have both alive and dead in the same relative frequency, but we don't want to do counts, not when we're trying to compare. Okay, here counts, no good. Don't do counts, not frequency. All right, so what if we looked at the same kind of thing for level of education? So we have males and females. In our sample, we have many more males than females, and we're going to do that same relative proportion. So 318 out of 1086, 603 out of 1086, 165 out of 1086, and we get these proportions. And then if I do that again, 212 divided by 724, 402 divided by 724, 110 divided by 724, and it looks like the same proportions. When we look at that as a segmented bar graph, we see that they're exactly the same in the segments. So since there's no difference between males and females based on their education, level of education, we would say that those two variables are independent. They don't affect each other. When they were dependent, back when we had the Titanic data, we could see a difference from one group to the next. Here, because they're the same, they are independent. So there's no association. All right, that's it for this one. We'll hit stem plots here in a minute.